anyone want to come solve any of these?
We volunteered.
You guys can't volunteer each other.
I just suggested we should all.
Let's say everyone that got 1 for number 1 was correct.
Yeah.
Does that make you feel better? Does anyone now want to come do number 1? Still no. Alright, so you may have done yours a little bit differently than how I'm about to do it, but I'm going to subtract 4x on both sides and add 12 on both sides. So this would be negative 10 plus 12, so 2. And 6 minus 4 is also 2. So x equals 1. Questions on that first one? Good job if you got that one. The answer to number 2 was 6. So if you got that, good job. Anyone want to come do number 2?
You definitely.
Jasmine, go for it.
Have you ever tried Fiji? No, very long. I don't like it. It's like beach water. It's fat sticky. I like Deer Park. I like Deer Park and it's okay, but so I like Deer Park. You drink rainwater? You like to drink water? But my friend's dog only drinks rainwater. He doesn't
You wait until what if there's a drought?
Oh,
No water.
they're so cool. Eventually. Oh my god.
Alright, everyone look at Jasmine's work. Yours might be a little bit different. And
I don't think she's a dog.
I'm going to talk through what Jasmine did. If I say anything, just correct me. So first, she combined her terms to 5 and, she distributed first and got these two, negative 5 over 2 plus 6. Some of you left that as negative 15 over 6. Either or, that's fine. And then combine the terms 5 and 6 to get 11. And then you have choices. Here, Desmond moved 5 halves over. If you did that in your calculator, it would simplify it for you down to 3. So then we have 3x minus 7 equals 11. Add 7 back to the other side. And then divide both sides by 3 to get 6. Do we have any questions on that one? In number 3, it was already solved for you. You just had to figure out what type of solution is represented by his work, and how do you know? Anyone want to share their answer for that one? Regina, go for it.
I think it's no solution because 2 doesn't equal 0. And also, at the beginning, they both have 3x, but not the same constant.
So any of those reasons you could have used. 6 doesn't equal 4, and they could have stopped there, but they kept going. 2 doesn't equal 0, so not true statements, the variable is gone. But also, if we stopped earlier, the coefficients are the same, but the constants are different. So all of those things. Okay. Number 4, if you want to try it, it's a little bit more complex than you'll see. But you could try it. I'm not going to go over that one right now. I don't believe we went over numbers 1 and 3 from the word problems. Did we need to see or go over either of those? If you are not at your seat, go back to it. And then today we're going to be talking about solving absolute value equations. So that's like a step up from what we were doing before. So first I'm going to have you fill out these steps. Step 1, make sure the absolute value expression is isolated. What does that mean? By itself. So we have to make sure the absolute value expression is by itself. Set the inside equation, equal to both positive and negative number from the other side of the equation. That'll make sense here in a second once we actually do it. Solve both equations. Write your answer as a solution set. So the solution set might be something new to you because usually we talk about that before we get here, but it's alright. But really, we're going to be using these curly brackets as part of our answer. Anyone still writing this down? So we're not going to do every single problem. We're going to do, I have a set number, and then if we want to go back and see some, we can do that. So starting with number 1. If we're looking back at our steps, make sure the absolute value expression is isolated. So they're talking about the absolute value bars in general. We don't want anything around it. We want it by itself. So if there's nothing around it, it's already isolated, so we don't have to do that. Because absolute value measures distance, it's going to be equal to a positive and negative version of whatever this is. So I'm going to set the inside, just x, equal to 2 and negative 2. Usually these would be equations that you would solve. In this case, we didn't have anything to solve, so we're kind of skipping step 3. And then because there's nothing else to solve, these are the final answers. We would write these as our answer in a solution set, least to greatest. Mine are supposed to be curly brackets. One doesn't really look like it, so to the best of your ability. But this is saying the answer to this problem are both of these things. Later, I'll show you in Desmos what this does, so when you're practicing on your own, you can use Desmos as a check yourself. Questions on that one? Let's move on to 3. Same thing, make sure your absolute value bars are isolated. There is nothing around this, so it is isolated. Then we're going to set the inside equal to a positive and negative version of this. And then we're going to solve both. So to get z by itself, we would divide both by 5. So that z equals what? 8, negative 8.
Or negative 8.
So I'm going to write it as is first, and then go back and rewrite it as the solution set. Once you get, I was going to say more comfortable, then you can go straight into the solution set. But I do want you to make sure you have the right answers before you just immediately put it in. Questions on that one? We're going to jump down to 5. Same thing. Our absolute value bars are already isolated, so we're going to set the inside equal to a positive and negative 8. And we're going to solve both. What would we do here? Subtract 1 to both of these. So D equals what? 7 and negative 9. So sometimes the numbers are the same, but just a negative, positive version of each other. Sometimes they're not at all. So negative 9, 7 would be our solution set. Questions so far? With each of these problems, we're just like adding another step to it. So let's try 7.
Does it matter which number goes first?
When you say first, you're talking about here. Do least to greatest. Right, so nothing outside the absolute value bars. We are going to get to some that do here in a second. Start solving both of those. You should have gotten negative 9 and 8. The biggest thing here is make sure you are setting it equal to a positive and negative version. If you only do one, you're missing half the answer. Questions on that one? Once you have this, turn it over to the back. We're going to do 9. If there is stuff outside of the absolute value bars, we're still going to isolate it because that was in our steps, that was our goal. So when we do that, we're going to pretend that the absolute value bars are just like a variable that we're trying to get by itself and then deal with anything inside later. So for this, I'm trying to get the absolute value bars by itself, so I need to get rid of the 2. I'm going to subtract that. Then, once it's isolated, then you can set the inside to the positive, negative. If there were more on the inside, you would solve both equations and then find those answers. But in this case, also, if you have the same number, positive and negative, instead of writing them both, if you wanted to write it like this, that would also be acceptable. That's a plus minus. It's saying the same thing as writing out negative 10 and positive 10. So either or, you don't have to write both. Questions on that one? Let's try number 12. So, is there something outside the absolute value bars? Yes. The negative 2, you need to get rid of it. How would we do that? Landon? Okay. So, if this was at the end, I would definitely say add 2, yes. But it's right next to the absolute value bars. So, what are those doing to each other already? Multiplying. So how would we undo that? Not distributing. Dividing. We're going to divide negative 2 on both sides. Then the absolute value bar is isolated. So we can set the inside equal to a positive and negative version. And solve both equations. So negative 10 and positive 4 would be in our solution set. What questions do we have about that one? Skip a couple and jump to 15. What would be our first step? Dylan? We are going to divide by 7. Would we do that first, though? No. Only because if I divided everything by 7, I'd have to divide everything by 7. So this and this. And you may end up with fractions that we don't want. So instead of dividing by 7, what could we do first? Add 6 to both sides. So now we're going to take what Dylan said and divide both sides by 7. What would that become? What? 16. We all get 16? Yes. Right? Then what would our next step be? Make the inside equal to both a negative and a positive. You may need more space, so you can use this extra space on the side. And then start to solve. So n equals -6 and 2. We're going to talk about some special cases, and then any others you want to see, go over, have questions about, we'll do those. Because for 17, yeah, this already equals a negative, and it's supposed to measure distance. Absolute value measures distance. It's already negative. I can't make it positive and negative since it's already starting with a negative. Absolute value can't be negative, so this would just be no solution. We can't answer it. We can't solve it. Some of you will try to solve it, but you shouldn't. Sometimes you won't know it's no solution until you start to solve it. So don't assume just because it's negative over here, like if there's things outside of the absolute value bars that we have to isolate first, and the other side is negative, don't assume it's going to be no solution, because it could change, but then it could also not. So for this one, we would need to divide both sides by -3. This became a negative, so now we can no longer solve it. So that would end up being no solution. You would stop right there. So there was a problem we did earlier that I want to say started off as a negative. But if we just assumed right here that it would be no solution, that would be wrong because it changed. So this is that explanation. The absolute value cannot equal a negative number once isolated. Once you are finished writing down that explanation, look through the problems we did not do, / the problems on the next 2 pages, or the page and front and back page. Find any questions you have. Yes. Go ahead and write your pass. So anything you see that you're not sure where to start, have questions about, anything like that. Did we find any that we want to see, go over, have questions about, Jasmine? 13. Any others? Elena? 10. Did it work? No. Regina? Sure.
On the last page, 11 and 13.
I don't have that. Hold on.
But you said 11 and 13. Okay. So let me just print this. So that'll take a second to print to a smart notebook.
Any others? So after we go through these, I'm going to show you one thing about the Khan Academy that's due on Friday that will help you, hopefully. There we go. Okay. 11 and 13. Alright. So starting with number 10. What should we do first? Add 8. Get rid of it by adding it, yes. So -5 plus 8 would give us a +3. So it was going to be a no solution, but it's now going to be a solution. Change the inside or make the inside equal to positive and negative version, and then make that your solution set. Daniela, I wrote your test. All right, questions on 10? Number 13. We need to get rid of the 6. What would we do? Multiply both sides by 6. So these 6's would cancel. So you have 2w minus 4 equals 18. So far, so good. We can keep solving because we have a positive answer. Set the inside equal to a positive and negative version. And then solve both equations. What were our two answers? Jada.
-7 and positive way.
Correct. Questions on 13? There's a lot going on here. What would we get rid of or do first? Add the 24 to both sides. And then, how would we get rid of that 3/2? We could do that. Instead of dividing by a fraction, what else could we do? Multiply it by its reciprocal. Take it, flip it, multiply on both sides. Okay, so this would become 6/3, which is just 2. Notice that I'm leaving the absolute value signs until the very end when there's nothing around it. I expect you to also be doing that. Then once you set it equal to both the positive and negative, drop them because you no longer need them. And then solve both of them. So one of these is going to end up a fraction or a decimal. As long as it's a nice fraction or decimal, that's fine. I'm sorry, both of these are. Just make sure they're reduced. And still in the right order. If you get two fractions and aren't sure which one is bigger than the other, look at your calculator, put it in as a, not the alpha y equals fraction, but just a regular fraction to see the decimal. This one's easy because one's negative, one's positive. If you wanted to put negative 0.5 and 1.5, that would also be fine. Questions on that one? And then find number 11 and 13 on the very last page. So 11 is kind of like the one we just did. How would we start solving this? Multiply by 2 on both sides. So the 2's cancel. We're left with the absolute value of 4x minus 12 equals 16. And then we can set it equal to a positive negative version. And negative 1 should have been the answers we got. But in solution set, negative 1, 7. Questions on that one? $13 is like the one we did on that last page, but it doesn't have all of the work. So how would we get rid of this 4/3? So take it, flip it, multiply by 3/4. Multiply 16 by 3/4. Tell me what that is. And then set it equal to the positive, negative, and solve both. Got negative 2 and 6. That was correct. On the back of your quick check where you have space, I want you to write this down. let's just do 1 for right now. Write this down, this first part. -2 times the absolute value of x minus 14 plus 5 equals -6 times the absolute value of x minus 14, minus 1. So just this one for right now.
These will be the problems that you'll see on the Khan Academy, and I wanted to walk you through it so you're not surprised. It looks complex, but once we move some things, it'll look similar to what we were just doing.
Right. This only works if you see that these insides are the same.
You won't see that they're not the same. So anything else doesn't matter.
And then you have to think about this like getting variables on the same side.
We want to get them both on the same side.
So it doesn't matter if I move this over here or this over here. Let's say I move this over here by adding 6.
When we move variables, we're really just moving or adding and subtracting the coefficient. Same thing here.
We are not adding the insides together, just the coefficient. So this part cancels. This becomes 4.
And now it looks more like the absolute value equation that we were just solving.
So I'm going to let you continue to solve that. Write this one down as well, just so you have another example.
And then, again, our goal is to get the insides to the same side. Doesn't matter how we do that. So, how do we want to move one or the other? Do we want to get rid of the -7? Do we want to get rid of the 2? Doesn't matter.
The 7, okay. So we would do what to get rid of this? Add it. So then these would cancel. We have -5 equals 9 times the absolute value of x plus 1 minus 5. I do want to actually solve this one because this is not one of the examples that we did before. If I started to solve this one, what would we do first? Mm-hmm. So we get what here? 0. Still have to isolate our absolute value, so divide both sides by 9. But will that change this? No, it'll still be 0.
If you get something like this, there is no such thing as a positive -0, so you would just set it equal to 0 one time. That's it. And you would solve. So in your solution set, you would just have one number instead of 2. That happens sometimes. Yes. Mm-hmm. So just like when solving regular equations, we can get one answer, we can get no solution. Infinitely many is not a thing with this one. And then you could get 2 with absolute value, 1, or none. Do we have any questions on how Khan Academy is going to show you this? Anything we did? Anything like that? So then you have a couple options. You can continue working in the notes on those practice. You can do the Khan Academy that's due on Friday, so you don't have to worry about it. Get it out the way. If you do those and want something else, or if you just want to do something else, I have a, remember what it is, scavenger hunt on absolute value that you could do. So if you want to do the scavenger hunt, I'll put them up and you can go do that. But you have to come see me to do that. Or you can work on Khan Academy, or you can work on these. But be working on